Okay, first question would be, what is data? And that's when we have a data situation that cannot be handled by normal methods. And the word normal methods can be kind of confusing. We're talking about the inability to use a typical relational database. Oftentimes, you can't even look at all of the data. So when we think we are converting really big data into something useful, we need to reflect on what we're doing. We consider it prudent to establish goals for analysis from the very beginning of whatever exercise we're involved in, whatever it is we're trying to find out from our big data. And in some cases, we have data quality issues. We dealt with that in another webinar that's available through ITMPI. We need to remember also that the consumption of big data can be costly, talking about vast amounts of data. And if we don't know what we're doing, we will consume resources for no purpose. Let's take a look at a application. And before we get started on that, I've listed here some topics. I always ask students, why do we care? Why should we care? I mean, big data, isn't that just a buzzword? No. The recent NSA revelations, for better or for worse, those are examples of big data usage. Department of Transportation, image capturing, things you see listed here, and discovery, which is part of the topic of today's talk. So, the Corporal Brickhouse indicates they can track a person, a car, some property, whatever. And a quick check on the internet that there are a substantial number of organizations that can provide this kind of information with names like LiveView GPS, Spy Associates, Vehicle Tracking. These are just a few suppliers of software and tools. GPS can apply to lodging, vehicular movement. We're talking train, bus, car, airplane. Some of the organizations use the cameras. Tagged photographs can be correlated to GPS log data. And if we need serious surveillance, we could use a GPS pusher that sends updates at some meaningful interval, allowing for mapping of movement and location. That's mapping the people watching us. That's a big data problem. In the stance of commercial vehicle use, it might make sense to track vehicles to eliminate vehicle and time clock abuse. And I think we've already seen that with tachographs in South America and some use of GPS in the United States and Canada. Minimal ethical issues when dealing with delivery trucks, large-scale haulers, taxicabs, and commercial vehicles and similar businesses. So, critical big data problem. And for the most part, when I've spoken with people, they're completely unaware of it. So I have a metaphor called the river, and specifically the Mississippi River, because when we go in to do data discovery, what are we going to do? You stand in front of something as vast as the Mississippi River. Even in the dry season, it's huge. And when we're in the flood season, of course, it's huger. Here is the best we can do is to look at the pieces. You notice I have the word sampling there. We divert portions of what we're looking at. We can use an approach called machine learning. And then, perhaps the most difficult of all, we have to take a look at what we've diverted and make sure that we're looking at what we think we're looking at. One of infant diversion was used by the much maligned Target Corporation. This has no bearing on their recent issues with security is the fact that they observed when they captured data, they could estimate whether a woman was likely to give birth relatively soon. And they made use of this in their marketing. And some people have had heartburn about this, but that's an example of data discovery. I don't think he was particularly trying to conceal the fact that a child was in the offing. And of course, any of us that use Amazon deal with this all the time. We know that Amazon is presenting to us of interest to us because Amazon already knows what we've looked at on their site. So let's continue. Well, principal methods, as I alluded, is machine learning. We can use algorithms and some fairly clever techniques to separate the wheat from the chaff. I'll return to this in a little bit, but you'll hear funky names like Bayesian techniques, case nearest neighbor, and so on. There are tree methods because we can't look at everything. And again, you see this river metaphor. It's, in essence, overpowering. Even in the days before we had what we would call really big data, we still had to do data reduction in order to dive into things and find out what was truly interesting, because not all data is of value. And of course, we use appropriate tools in order to allow us to function in this big data world. Example. The Apache Foundation tool for creating distributed clusters of servers, purpose of doing what I call spreading the wealth. And the picture you see here is a 6 strategic bomber. You can see it had 6 prop engines, and later they added jet engines. They spreaded the wealth. The wingspan on this thing was unbelievable. And the point here is exactly what I say. A heavy load requires more engines. What Hadoop does is it allows us to spread out what we're doing over all the hardware that we have. Now, people may remember back into the olden days of, say, the 80s, where we could do things like master-slave multiprocessing, symmetric multiprocessing, and so on. Hadoop, the big benefit here is it's open source and free, for one thing. It's been rather well tested for another, and it has taken over the big data world so much it is effectively the solution to the distribution problem. So once we have control of our hardware, well, how do we submit problems to this? Because simply having Hadoop is not sufficient. The next step is to use a tool called MapReduce. And MapReduce is basically a gift from Google. They described it in a journal article, and individuals basically took that information and have produced different versions of MapReduce that will make use of the availability of distributed hardware. And what you do is you submit a problem,